Hey everybody. Today we're representing functions with power series. So whenever you have a power series, like sum from n equals 0 to infinity c sub n x to the n, you define a function. The domain of that function is going to be the interval of convergence of that series. So the natural question to ask is, does that series ever represent a function that we already know? The answer is yes, and in fact we've already seen one example of that. Sum from n equals 0 to infinity, x to the n. This is a geometric series with a equals 1 and r equals x. So it's equal to 1 over 1 minus x and converges for the absolute value of x less than 1. That's a very useful fact, and we can use that series representation to help us find series representations for many other functions. For example, 1 over 1 plus x squared. So obviously you can see the similarity between these two functions, 1 over 1 minus x and 1 over 1 plus x squared. So I'm just going to write it slightly differently, 1 over 1 minus negative x squared, and then take that negative x squared and substitute it into my power series. Take out the x and replace it with negative x squared. I can simplify this very slightly to get the sum from n equals 0 to infinity, negative 1 to the n, x to the 2n, which is 1 minus x squared plus x to the 4th minus x to the 6th, and so on. Now, that series is going to converge whenever the absolute value of negative x squared is less than 1. In other words, when x is less than 1 in absolute value. Let's do a slightly harder example. X cubed over 1 plus 9x. So I want to try and rewrite this so that it looks a little bit more like 1 over 1 minus something. So first of all, I'm just going to take out that x cubed, and then in the denominator, I'm going to rewrite the plus 9x as a minus negative 9x. Now that fraction, 1 over 1 minus negative 9x, I can get a power series for right away, just using the formula for 1 over 1 minus x that we had previously. And then the x cubed, I'm just keeping on the outside. Simplifying the inside just a tiny bit, I get negative 9 to the n, x to the n, and then bringing the x cubed inside, x to the n times x to the third is going to be x to the n plus 3. Technically, we're already done here. I'm just going to rewrite it slightly so that it looks a little nicer. Sum from n equals 3 to infinity, negative 9 to the n minus 3, x to the n. We can also talk about convergence here. It's going to converge whenever the negative 9x is less than 1 in absolute value. In other words, when the absolute value of x is less than a ninth. One last example. X over 4 minus x. So again, I want to try and write this so that it looks more like 1 over 1 minus x. So I'm going to pull out the x on the top, of course. On the denominator, I'm going to pull out a 4. That way I have 1 minus something. I'm left with 1 over 1 minus x to the 4th. And I can write a power series representation for that. Sum from n equals 0 to infinity, x over 4 to the n. Now, the factor out front, x over 4, is identical to the factor inside. So this is the sum of x over 4 to the n plus 1. Or, to say it a little bit differently, the sum from n equals 1 to infinity, x over 4 to the n. Radius of convergence is going to be 4 here because it's going to converge when the absolute value of x over 4 is less than 1. In other words, whenever the absolute value of x is less than 4.